Today we're going to work out the dimensional analysis problems that are examples in the back of your notes for the math and mole unit. The purpose of dimensional analysis is to set up a math problem where we're actually canceling out units one step at a time. And as we can cancel out units one step at a time, in the example problem here we have kilograms. We're going to take that to pounds. How we go from kilograms to pounds, or years to seconds, or feet to inches, or whatever else, is we use these conversion factors that are listed in the back of your notes, or I have extra copies in the classroom. Now with all of these different conversion factors that are here, we've got all these different things. I do want to point out in the bottom down here, these conversion factors you can fill in wherever it says base unit, meter, liter, gram, or second. So if it says millibase and we're dealing with grams, it would be a milligram, and this would just be a gram. So with your conversions, these are all a little bit different, but these are your metric conversions that we did at the beginning of the year. Now your first step in any dimensional analysis problem is to start with the number that's given in the question, which this one says convert 4,800 kilograms to pounds. So I'm going to start with 4,800 kilograms, and I want to convert that to pounds. Now there's two ways of setting up your math problems. I don't mind which way you do it. It's totally up to you and whichever method makes sense to you. So the first way is by using a multiplication sign, and then you're going to pull your conversion factor out and you're going to put one part of the conversion factor on top, one part of the conversion factor on the bottom. Now, first thing, we have kilograms, we want to go to pounds. We're going to look at our conversion factor sheet to see, can we go straight from kilograms to pounds? Which, if we look at this conversion factor, 1 kilogram is equal to 2.2 pounds. We only need one conversion in this problem. So with our problem, we have your 4,800 kilograms. Because I have kilograms on the top of this step, kilograms has to go in the bottom of the next step to get it to cancel. So on my conversion factor sheet it says 1 kilogram. So I write down 1 kilogram is equal to 2.2 pounds. So 2.2 pounds. Because we have the unit kilogram on top and bottom, that unit cancels out. So now to get my answer, what I'm going to do is I'm going to multiply across the top. So I take 4,800 times 2.2 equals, so we get 10,560. And then we divide by everything that's on the bottom. So if we had more than one number, we'd multiply across. In this case, it's just 1. So that means that our answer is 10,560. The unit that didn't cancel is pounds, LBS. Now, Sig Figs are important when we're doing math problems. These are conversion factors, so they're exact numbers, they're not measurements. So we look at the first measurement right there. This number has 2 significant figures. So if that number has 2 Sig Figs, my answer can only have 2 Sig Figs. So to round to the right number of Sig Figs, we read from left to right. So I need the first 2 places. So that 0 becomes a 1 because the 5 makes it round up. I fill in my 3 space holder zeros, and we get pounds. So this has 2 Sig Figs and 2 Sig Figs. Now the other way of doing this math problem, you still start with your 4,800 kilograms, but instead of putting times and then a line, you can just do it this way. Now it's implied right here that there's a little multiplication sign, but we normally don't write it. So we still have 1 kilogram that needs to go on the bottom, and that's equal to 2.2 pounds. So it's the same thing, it's just you're doing a line instead of a times and then a little line. Again, kilograms cancels because it's on top and bottom, so then you'll get the same answer. For my next example, it says that we have 22.5 hours and we want to convert that to seconds. So again, you start with your 22.5 hours and we want to convert that out to seconds. So these conversions you might actually know, but in case you don't, they're on the conversion factor sheet. And we need to get a game plan. So in order to get our game plan, what we're going to do is we're going to look at our conversions, and we're going to look to see, can we go directly from hours to seconds? Which, using these conversions, there is nothing written that goes straight from hours to seconds. So I'm going to look for hours in my conversions. That one right there has hours. 24 hours is equal to 1 day. And 1 hour is equal to 60 minutes. So I have two options here. So I'm going to go to the unit that I wanted, which was seconds. The conversion factor with seconds is right there. 60 seconds is equal to 1 minute. So that means that if I use this conversion factor and this conversion factor, those two will actually get me somewhere. I'm not going to use this one because it's going to go to days, and I don't have either of that unit in those two conversions. So the first thing that we're going to do, I'm just going to use the one with the line, is we're going to pull out our conversions. The conversion with hour that we decided to use is 1 hour is equal to 60 minutes. So 1 hour is equal to 60 minutes. So hours on top and on bottom, they cancel. That leaves me with minutes. That isn't the unit that it's asking for. I need seconds. So what I'm going to do is in my next step, I now have minutes on top. So minutes has to go in the bottom to cancel. I look at my conversions, and it says that 1 minute is equal to 60 seconds. So 1 minute is equal to 60 seconds. Because I have minutes on top and on bottom, they cancel, and that leaves me with seconds, which is what the question asked for. So once I have that, now what I'm going to do is I multiply all the way across the top. 22.5 times 60 times 60. So you get 81,000 divided by 1 times 1, which is just 1. So we get an answer of 81,000, and then the unit that canceled or didn't cancel was seconds. Now with Sig Figs, I started with 3 Sig Figs down here. I need 3 Sig Figs down here. To get the right number of Sig Figs, what I'm going to do is I move my decimal place, because this is 2 Sig Figs, that's 5, so I need 3. I'm going to move my decimal place 1, 2, 3, 4 times. We get 8.10 times 10. Now I forgot how many. 1, 2, 3, 4 times 10 to the 4th seconds. So we had to put that one in scientific notation to get the correct number of Sig Figs. If we didn't do that, we wouldn't get Sig Figs that way. Now the last problem that we have, it says convert 6.9 gallons into drops. So again, I start with the number that's in my question. So I have 6.9 gallons. I need to know how many drops that equals. So I'm going to look at my conversion factor sheet. And I don't see anything that goes straight from gallons to drops. So I need a couple steps on this one. Now with my gallons, it says that there's 0.264 gallons in 1 liter. If I go to the unit that I need at the end, it says drops. 20 drops is equal to 1 milliliter. So somehow I need to get from milliliters to liters. To get from milliliters to liters, if we look at the bottom down here, milliliter, so 1,000 milliliters is equal to 1 liter in this case. So I'm going to use that conversion factor as well. So again, I start with the number that's given, which is 6.9 gallons. And I'm going to look at my conversion, which it says that there's 0.264 gallon in 1 liter. Because I have gallon on top and on bottom, they cancel. That leaves me with liters. So with my liters, I'm going to use my next conversion factor, that 1 liter is equal to 1,000 milliliters. So if I have liters on top, liters has to go in the bottom. That's equal to 1,000 milliliters. So now if I have milliliters here, that's where I can use this last one that says 20 drops is equal to 1 milliliter. So 1 milliliter, that cancels, is equal to 20 drops. So everything cancels except for drops, which is what the question asked for. So now what I'm going to do is I need to do the math. To do the math, I'm going to take 6.9 times 1 times 1,000 times 20. It equals, I get 138,000 divided by 0.264 times 1 times 1, which is 0.264. So now I'm going to divide those two. 138,000 divided by 0.264, and this is what my calculator says. I need 2 Sig Figs. So if I need 2 Sig Figs, I take the 5, I take the 2. Now 52 is not the same as this big number. So what we need to do is we need to fill in 1, 2, 3, 4 spaceholder zeros to make it still approximately the same number. So when I do that, we get the 520,000 drops. If you wanted to put that in scientific notation, you could have as well. You would have ended up with the 5.2 times 10 to the 5th drops. It's the same number either way. I don't mind which way you write your answer, whether it's a long way or scientific notation, as long as you have the right number of Sig Figs.